Hi everyone. On today's session, we will be talking about probability theory. तो probability theory के बारे में जानने के लिए ये वाला सेशन मैंने बनाया है ताकि बेसिक्स ऑफ probability theory मैं पहले बता दे सकूं और उसके बाद उस रिगार्डिंग कुछ प्रॉब्लम्स और प्रॉब्लम्स के सॉल्यूशंस कैसे निकालते हैं वो देख सकूं। तो चलिए स्टार्ट करते हैं। प्रोबेबिलिटी थ्योरी स्टार्ट करने से पहले कुछ बेसिक टर्म्स हमें पता होना चाहिए प्रोबेबिलिटी थ्योरी के प्रॉब्लम्स के सॉल्यूशंस निकालने के लिए। जैसे कि हम इस वक्त व्हाइट बोर्ड में देख सकते हैं कुछ टर्म्स लिखे गए हैं, तो एक एक करके टर्म्स के बारे में हम समझते हैं। पहला टर्म है सैंपल स्पेस। सो व्हाट इज सैंपल स्पेस? सैंपल स्पेस इज द प्लेस वेयर वी टॉक अबाउट the total number of events or the total number of occurrence of any events. Okay, so that is called sample space. फॉर एग्जाम्पल अगर मैं लास्ट जो मैंने वीडियो बनाया था ऑन कॉम्बिनेटोरिक्स, उस वीडियो का जो लास्ट प्रॉब्लम था वो प्रॉब्लम कुछ ऐसा था कि देयर आर 49 टिकट्स। ओके, 49 लॉटरी टिकट्स वर देयर, out of which 49 lottery tickets, out of which we need to choose 6 tickets. Okay, I mean in this way that the question was this, that what are the chances of winning a person can win a lottery ticket if randomly 6 tickets are going to be chosen out of 49 tickets. ओके, सो यानी कि 49 टिकट्स में अगर मैं 6 टिकट रैंडमली उठाता हूं कहीं से भी, क्या प्रोबेबिलिटी है कि उनमें से कोई एक टिकट जीतेगा, मतलब लॉटरी जीत पाएगा? ये था मेरा सवाल। तो इस सवाल के सैंपल स्पेस क्या बनेंगे? तो अगर हम आउट ऑफ 49 6 टिकट्स उठा रहे हैं, तो इस सवाल के लिए हमारे सैंपल स्पेस बनेंगे 49 चूज 6। ओके, क्योंकि the total number of choices are 49C6। ऑलराइट, जिन्होंने भी प्रीवियस वीडियोस मेरे देखे हुए हैं कॉम्बिनेटोरिक्स के, उनको ये बात समझ में आ गई होगी ऑलरेडी। सो और क्या समझ सकते हैं सैंपल स्पेस के बारे में? फॉर एग्जांपल एक डाइस है, ठीक है ना, एक डाइस है। हम लोग बचपन में लूडो जरूर खेले होंगे। सो एक डाइस में कितने नंबर्स होते हैं? 1 2 3 4 5 6। So total number of possibilities or total number of possibilities is also called sample space. यानी कि in a set of numbers only these can be the possible events. None of the events can occur out of these events. Okay, for example मैंने एक रोल डाइस किया, तो मुझे सिर्फ और सिर्फ इनमें से ही एक नंबर मिल पाएगा इन ऑर्डर टू सॉल्व इट। ऑलराइट, तो चलिए नेक्स्ट पार्ट में जाते हैं। नेक्स्ट पार्ट है इवेंट्स। यहाँ पे और एक सैंपल स्पेस छोटा सा एक एग्जांपल में दिखा रहा हूं, वो है फॉर एग्जांपल एक कॉइन हमने टॉस किया, तो उसके सैंपल स्पेस क्या होंगे? हेड एंड टेल। सो दीज आर द ओनली टू सैंपल स्पेस ऑफ any toss. Okay, so if I talk about events, then it is like this, that what are the chances are there? So probability theory is all about counting the number of chances of happening an event. So event means in this way, for example अगर मैं सवाल पूछा किसी से कि मैंने एक कॉइन को टॉस किया, तो क्या चांसेस है कि उस कॉइन में हेड आएगा या फिर टेल आएगा? सो अगर हेड आता है तो वो एक इवेंट की तरह ट्रीट होता है। अगर टेल आता है तो वो एक वो भी एक इवेंट की तरह ट्रीट होता है। सो एक सैंपल स्पेस होता है, उनमें से कोई इवेंट अगर ऑकर करता है, कोई भी एक पर्टिकुलर एलिमेंट ऑकर करता है, तो उसको हम एक इवेंट कहते हैं। सो बेसिकली it is I mean event is subset of sample space. All right, So number of events can occur out of, it will be always be lesser than or equals to the sample space. All right. So चलिए देखते हैं next definition of complementary events. So complementary events means, for example, there is a sample space. All right, I'm making a Venn diagram. So only this much of events are happening. So the rest of the events are complement of these events. So if it is a complementary events, it means that the probability will be like E union E complement equals to 1. So we all know that probability will never be greater than 1. यानी कि कोई भी इवेंट अगर ऑकर करता ही करता है तो उसका इवेंट का प्रोबेबिलिटी मैक्सिमम जो हो सकता है वो है 1. और अगर हम कोई सैंपल स्पेस में कॉम्प्लीमेंटरी इवेंट्स और वो इवेंट्स का यूनियन निकाले, ऑकरेंस ऑफ दैट इवेंट्स का यूनियन निकाले, तो हमें वो 1 ही मिलता है. तो E of C, EC is the complementary event of E. So, for example, after dicing a roll, if I count only odd number of events, then it will be 1, 3, and 5. Occurrence of 1, 3, and 5, if I take it as E, then E complement will be 2, 4, and 6. All right. I hope you got this correctly. What is complementary events? So let's see the next definition now. Mutually exclusive events. So what are mutually exclusive events? For example, एक sample space है, ठीक है ना, एक sample space है. अब उस sample space में दो different event हो रहा है. For example, P and Q. तो ये दोनों event में एक दूसरे के साथ कोई dependency नहीं है इन events के, right? Sorry, not dependency, rather ये sample space same choose किया जा रहा है. This is the sample space, entire sample, but the events are dependent. Independent. Okay, in that particular sample space, then it is called mutually exclusive events. For example, this occurring 3 after rolling a dice and occurring 6 after rolling a dice. So if the two dice are different, then there is no, no dependency between each other. So that is the reason why it is called mutually exclusive events. यानी कि अगर सैंपल स्पेस सेम है लेकिन फिर भी अगर हम दो डिफरेंट चॉइस लेते हैं तो उसमें इवेंट्स के ऑकरेंस अलग अलग हो जाता है. तो चलिए देखते हैं इंडिपेंडेंट इवेंट्स क्या होता है. इंडिपेंडेंट इवेंट्स मतलब सैंपल स्पेस ही अलग है, मतलब दो चीज पूरा अलग अलग चीज है. तो रोलिंग अ डाइस एंड चूजिंग अ कॉइन इज 2 डिफरेंट इवेंट्स. सो इसमें P एंड Q अगर दो पॉसिबिलिटीज है इवेंट्स ऑकरेंस के, ऑलराइट, तो वहां पे हम देख पाएंगे कि एक दूसरे के साथ दूसरा का कोई करेक्शन ही नहीं है. यानी कि ऑकरेंस ऑफ हेड और टेल is never be dependent on occurrence of any one number in a dice after rolling it. Okay, so the difference between independent events and mutually exclusive events are the sample spaces are different, but here the sample spaces are same. So sample space same hoga. For example, rolling a dice, if I choose first time I am rolling a dice and I am getting 3, second time I'm choosing rolling a dice, I'm getting 6. So like this, if I independently count the occurrence of 6 and 3, then it is mutually exclusive. And if it is dependent, then it will be if it is independent, then it will be both the different sample space. And if it is dependent, then it will be kind of this. There are situations where we will see this kind of situation where there is some intersection between the sample spaces. The occurrences of events. So that is also possible. So we will be taking now a few examples and solving a few problems through which our understanding will be more clear to this particular things. Okay. So I'll be start with the very basic example. All right. So before starting that, the final definition of probability theory I'll explain. Then I'll start. Okay. So the definition of probability says that the number of occurrence, the number of ways an event can occur, the number of ways an event can occur divided by number of ways sample space can be chosen. I hope you got it. So number of ways an event can occur divided by a number of ways sample space can be chosen. So this is called probability. So it is like this, like the way we write it, like P of E rather. Sorry, it's not by S. So the thing actually happens in this way. Occurring an event, if I calculate the probability, then it is P of E, or we can think it in this way, that occurrence of an event divided by S. So the same idea, but people usually do not use this terminology or this kind of notation. So people use this. So probability theory says that एक event occur कर रहा है out of the sample space whatever is given over there. Okay. तो एक एग्जांपल लेके अब समझेंगे. So my first example is very simple, very simple. I mean, you know it already. Like whoever will be watching this video, he or she is also known to this fact. So there is a unbiased coin. Now, difference between unbiased and biased coin is this: unbiased coin. All right. So difference between unbiased and biased coin is that if it is an unbiased coin, just give me a moment. Yeah. So if it is an unbiased coin, then the coin will be fair coin. It means if you choose, if you toss the coin, so there is a fair amount of chance of getting a head or a tail. But if it is a biased coin, then maybe the both ends are head or the both ends are tail, or maybe the head side is having more weight, or the tail side is having more weight. So it is not a biased or balanced coin. Okay. So the question is this: if it is an unbiased coin, then what is the chance of getting a head? If an unbiased coin is tossed, if it is tossed, then what is the chance of getting a head? What is the chance of getting a head? So everyone knows this answer. So only our sample space is head and tail, right? Yes. And our event is only head. So P of E will be 1 by 2. As I have written before, that number of occurrence of event divided by number of ways we can choose the solution region. I mean the sample space. So we are having this sample space head and tail. So total number of possibilities of occurring an event is half. Okay. So this will be the answer. So simple. But the next question will be a little bit trickier than this one. So consider there are three or so rather there is a unbiased coin tossed for 3 times. Okay, there is an unbiased coin which is tossed for 3 times. What is the chance of getting exactly 2 heads? If it is a question, what is the chance of getting exactly 2 heads? What is the chance of getting exactly 2 heads? So this question can be solved in this way. Simple. This is also very simple. So this is a coin, for example, right? So it is tossed first time. So what is it? There is the possibility of having head or having tail. Now after getting this head or tail, Again, this coin is tossed. Okay. Again, this coin is tossed. So the possibility after getting a head is again head or tail, or the similar way we can form in this thing. In the case of tail, head or tail, both can come. And again, we can choose because this is tossed 3 times. So head, tail, again head, tail, again head, tail, again head and tail. All right. Now एक कॉइन को मैंने अगर 8 बार सॉरी 3 बार टॉस किया है, so total number of formation of these coins will be like this: head, 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 tail, head, tail, head, head, tail, tail, head, head, sorry, tail, head, head, tail, head, tail, 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 head, tail, tail, tail. So total three three times we have tossed. So first time, this is first occurrence, this is second occurrence, this is third occurrence. Okay. So all the possibilities I have written. So this is my sample space. All right. This is my sample space. So my question was, what is the chance of getting exactly 2 heads? So exactly 2 head means this one I can choose, this one I can choose, and this one I can choose. And there is no other possibilities. So total sample space is 8, and only 3 are the chances of having exactly 2 heads. So this will be the correct answer. 3/8. I hope you people understand this solution, how to do it. Okay. So if I twist this problem, or if I after tossing a coin, so at least one tail I will get. So see what are the chances of having exactly, I mean at least one tail. So this one, at least one. So 2 is also counted. This one, this one, this one, this one, this one. So the probability will be 7/8. All right. Why 7/8? You can count it like only apart from head, 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 all the conditions are having this total at least one tail. So there is more than one tail possibilities are also there. So everything can happen. Now, if I change the question another time, and my question is, for example, like this. If my question is like this, after having a tail, coin is tossed 3 times only, but after having a tail, what are the chances having tail? What are the chances having exactly one head? One head. So look at the sample space again. So head, 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 tail, head. So ये काउंट नहीं होंगे क्योंकि शुरू में ही टेल आ जाएगा, राइट? So if I choose only tail, so sample space will be 4. Okay. And for this problem, P dash, for example, or P double dash, this one is P single dash, because 3 problems are different, so that is the reason why I am naming it differently. So starting with tail, and what was my question? Exactly one head. So यहाँ पे exactly one head मिल रहा है, यहाँ पे exactly one head मिल रहा है, right? So only 2 cases where I am founding one head exactly. So it will be 1/2. So like this, we can approach to the problem and solve it quite easily. Now, it seems like the problems are very, very easy. But let me tell you something. that all the problems are not easy as this problem, because I can form this problem in this way, like in a tree structure. I'm trying to break it and solving it, but not necessarily all the problems will be coming your way in this way. Okay, so the next time onwards, I'll show you better approach to solve problems if the number of tosses increased or something, some other kind of things will happen. Okay, so there are things like conditional probability, binomial distribution, and there are several other Poisson distribution. There are several other different types of approaches in order to solve a probability problem. So we will see that those. Let's take another example. Let's take another example. So in this example, we will be seeing that there is a coin. So there is a sorry, there is a dice, unbiased dice. Okay, uh, which is rolled, rolled on the floor. And what are the chances of having? What are the chances of getting an even number? Even number. So our sample space is what? In a dice, there are only 1, 2, 3, 4, 5, 6. Okay. So this is our sample space. All right. So in this sample space, the chances of having an even number is only, which is a subset, of course, is 2, 4, and 6. So the probability of occurring that event will be only 3, right? 1, 2, 3 possibilities are there out of 6 possibilities. So it will be half. Half is the probability. Okay. So these are the basic idea and very basic understandings of probability theory. The next class when I'll go into one step difficult problem, which problem very interesting to solve those problems, and I'll show you